Hey, Algebra 2, we're going to continue in our systems of equations and graphing them. And like I said in the last lesson, I've been using Desmos. I'm not sure how to pronounce it. It's an app I downloaded onto my MacBook, and it is phenomenal. It's what I've been using, and of course I'm able to, copy, take a picture, and paste it into the lesson. And if you're using it for homework, it's sort of hard for you to show me what's going on. But I would really stress to go ahead and download this application and get used to using it. It's really fantastic. All right, let's start out with just a little mini lesson. Suppose you have a point A with coordinates 1, 3, and we need to find the distance AB if B has the coordinates that are given. And what I want to remind you is, do you remember Pythagoras and the Pythagorean theorem? So this first problem, I'm going between 1, 3 and 4, 2. So over 1 up 3 and over 4 up 2. In this first problem, I didn't put the entire x and y coordinate or x and y graph axis on there, so it's sort of hard to see. But what I'm going to do right now is I'm trying to find the distance between these 2 points, which is that length. And how we develop that is I'm going to draw a right triangle here. So we're trying to find the distance between A and B. There's A and there's B. If we remember, let's see, this is 1, 2, 4, 6. That's 3. I can figure out the distance between A and B doing 1 squared plus 3 squared equals AB squared. This gives me 1 plus 9 equals AB squared. Take the square root of both sides, and AB equals square root of 10. Pretty simple. Let's draw my right triangle here. This is 1, 2, 1, 2, 3, 4. So AB squared is going to be 4 squared plus 2 squared. 16 plus 4. So AB is the square root of 20, which simplifies to 2 square roots of 5. Now let's see if we can do the distance formula with what we've done so far. I'm going to go back here to the original 2 problems. So those are the 2 points we're trying to find the distance between. And if I look at the x's, I have 4 and 1, and the y's, I have 3 and 2. So it looks like this term is going to be my y term. I did it backwards, but that's all right. 3 minus 2, quantity squared, 3 minus 2, and then 1 minus 4, quantity squared, realizing that this one right here gives me a negative, but when I square a negative, it comes out positive. So there's my x term. To continue on to this thought process, that equals AB squared. If I want to get rid of this squared, I need to take the square root of all of it. And we've just developed our distance formula. It's all about Pythagoras. So let's write that down. My distance formula, AB is the square root of the difference in x's plus the difference in y's squared, all underneath a radical. So let's go ahead and check it out with this last one. I have the square root of x minus 1 squared plus y minus 3 squared. And that is going to be the distance between the 2 points. Okay, that's your answer to that last one. All right, opening exercise. Given the line y equals 2x, is there a point on the line at a distance 3 from point 1, 3? Explain how you know. So let's do this. Let's go over 1, up 1, 2, 3. That's an awful point. There we go. So given the line y equals 2x, is there a point on the line at a distance 3 from point 1, 3? Explain how you know. So there are actually two such points. We're going to do the intersection of the line y equals 2x and a circle. And that circle is going to have a center of 1, 3 and a radius of 3 because we want it to be, we want it to be a distance 3 from the point. Okay, so if we do a radius of 3 with this as the center, we will get that the two intersections. Say we need our y equals 2x, and then our equation for the circle, if you remember, it's x minus h, and h being one of the x coordinate of the center plus y minus k, and k being the y value of the coordinate for the center, equals the radius squared, which is 9. Okay, and if we look at the next slide, we'll see that I've graphed both of these things. And there it is. We see the intersection of the line and the circle in two places. The intersection points, just looking at the software, about 0.07 and 0.15, and about 2.73 and 5.45. Cool. Right. So let's solve a system of equations. We've talked a little bit about where their solutions are. It's where the two equations intersect, and we can come up with the values where they intersect by doing some algebra. So solve the system x minus 1 quantity squared plus x minus 2 quantity squared equals 2 squared, and y equals 2x plus 2. So let's first substitute that y equals 2x plus 2 to find our x coordinates. So we have, actually I'm going to push pause and work on this, and you work on it too, and let's see if we can come up with the same answer. Alright, here you go. I haven't found y yet, but if we plug in, oh goodness, if we plug in x equals 1 to that equation of a line, I would get 2 plus 2, y equals 4. Then if I plugged in x equals negative 3/5, I get negative 6/5 plus 5/10, which would give me positive 4/5. Let me do that again. My mind got jumbled. Y equals negative 6/5 plus 10/5 gives me 4/5. So my two answers, 1, 4 and negative 3/5, 4/5. That is a negative 3/5. Cool. All right, what are the coordinates of the center of the circle? If I look right up here, my coordinates of the center are 1, 2, and my radius is 2. I didn't ask that, but we know it. That's an awesome spelling of radius, isn't it? What can you say about the distance from the intersection points to the center of the circle? My center was 1, 2. Sorry, my center was 1, 2. Let's write that over here. One of my intersection points was 1, 4, and the other one was negative 3/5, 4/5. So even if I look at this graph, the distance from the intersection points to the center, that right there is 2, which is the radius. Oops. And this right here is going to be 2 also, which we could figure out using the distance formula, or Pythagorean theorem. You remember, we would do x minus x. This is 1 comma 2. X minus x would be 1 minus a negative 3/5 squared plus 2 minus 4/5 quantity squared. 1 minus, getting out the handy dandy calculator, negative 3/5 squared, 2.56, 2 minus 4/5 squared, 1.44 plus 2.56 equals 4. Sweet. So, because they are points on the circle and the radius of the circle is 2, the intersection points are 2 units away from the center. This can be verified by the distance formula. And then I did use a graphing tool to graph the line and the circle. Okay, example 1. Rewrite x squared plus y squared minus 4x plus 2y equals negative 1 by completing the square in both x and y. Describe the circle represented by this equation. Okay, you guys remember completing the square? I remember you love completing the square. Okay, so I'm going to just set things up a little bit. Y squared plus 2y plus... Okay, so give me a second and we'll come back. You guys work on it too. That actually wasn't too bad. We see that our center is going to be 2, negative 1, and our radius is 2. Okay, which is what I did. My center is over 2, down 1. So that is done there. Let's move on to the next one. In contrast, consider the following equation. X squared plus y squared minus 2x minus 8y equals negative 19. So let's go ahead and try to solve this one. Let's rearrange some terms. X squared minus 2x plus something. Y squared minus 8y plus something equals negative 19 plus plus. Let's see, I'm going to go ahead and add a 1 here and a 16 there. So add a 1, add a 16. Ooh, I already see a problem. Can't have a radius of a negative 2. So x minus 1 quantity squared plus y minus 4 quantity squared. The radius would be square root of negative 2, which is not possible, right? Can't have a negative distance or negative measurements. I plugged it into the graphing tool and nothing came through. It can't compute negative radius, so the graph was empty. That was 2 dots. Okay, so consider a circle with radius 5 and another circle with radius 3. Let D represent the distance between the two centers. We want to know how many intersections there are of these two circles for the different values of D. Draw figures for each case. I put it into the graphing software, and first I just did x squared plus y squared equals 25, and then x squared plus y squared equals 9. Excuse me. So I messed with, actually not that one. I messed with this equation and just did x minus 5, nope, x minus 8. So this one has 0, 0. And this was 1, 2, 3, 4, 5, 6, 7, 8. X minus 8 quantity squared plus y squared equals 9. What happens if the distance equals 8, which is what I did here, 1, 2, 3, 4, 5, 6, 7, 8. How many intersections are there? If the distance is 8, then the circles touch at only one point. So we say at that point that the circles are externally tangent. So they're tangent on the outside of the circles. What happens if the distance equals 10? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is x minus 10 plus y squared. At that point, if we look that the circles don't intersect, so that was an easy one. Neither circle is inside the other, they don't intersect, there's just no intersections at all. So if we were looking for a solution, there wouldn't be any. If the distance equals 1, the circles don't intersect, but one circle is inside the other. So we have a radius and a center and a center. What happens if D is 2? Let's see. At that point, when the distance is 2, the circles touch at only one point, with one circle inside the other. We call these internally tangent. Okay, for which values of D do the circles intersect in exactly one point? Generalize the results to circles of any radius. So if we looked, when D equaled 8 and when D equaled 2, okay, how would we generalize this to anything? So remember, a radius of 1 was, goodness, what was it? 5, and the radius of the other was 3. So the sum and the difference of the radii, if the distance equals, realize I didn't put that in proper English. If the distance equals the sum or the distance, if the distance equals the sum or the difference of the radii, then they're tangent. For which values of D do the circles intersect in 2 points? Generalize the result to circles of any radius. So for here, for our example, we have between 2 and 8. Then they intersect in 2 points. But to generalize, if D is between the sum or difference of the radii, then the circles intersect in 2 points. For which values of d do the circles not intersect? So if you had d of less than 2 or d greater than 8 for our example, but in general, if d is smaller than the difference, which was 2 in our case, of the radii, or larger than the sum of the radii, then the circles don't intersect. All right, another example. So find the distance between the centers of the two circles with the equations below, and use that distance to determine how many points these circles intersect. So basically, ignore this. Let's do the math first. The center of the first equation is 0, 0. The center of the second equation is 2, 1. And we're just going to find the distance between those two. So if we do distance equals 2 minus 0 squared plus 1 minus 0 squared, 4 plus 1. The distance is the square root of 5, right? So since the distance between the centers is between the sum and the difference of the two radii, here we have a radius of square root of 5 and a radius of the square root of 3. If we add these together, sorry, I needed my calculator to get an estimate. The sum of square root of 5 plus the square root of 3 is approximately 4. And the difference, square root of 5 minus the square root of 3, make sure when you do this on your calculator, it's actually square root 5 minus square root 3. They don't go both underneath the radical. The difference would be approximately 0.5. And the square root of 5 is 2.2. So since this is between the sum and the difference, then we should get 2 intersections, which when I graphed them on my software, I did. Exercise 3. Use the distance formula to show algebraically and graphically that the following two circles do not intersect. Okay, so let's look at the centers. The center of one circle is 1 comma negative 2, and the center of the other circle is negative 5 comma 4. Let's do the distance between those. 1 minus negative 5 squared plus negative 2 minus 4 squared. 6 squared plus 6 squared is 36 plus 36. And that is 72, which actually simplifies to 6 square roots of 2. So that's the distance between the two. The radius of this one is 1, and the radius here is 2. So the sum is 3. The difference is 1. What is 6 square root of 2? 6 times square root of 2 is 8.5. 8.5 does not lie in between these two numbers, so there is no intersection. Okay, this last example is pretty involved, so if you're getting tired, maybe you should take a break, go get a snack, and come back, and then we can work on this last one. We have point A is on a circle whose center is given. What is the radius of the circle? If we find the distance between those 2 points, we will find the radius. So the distance is going to be the square root of 3 minus a negative 2 squared plus 2 minus 3 squared. So I have the square root of 25 plus 1, square root of 26. That is my radius. What is the equation of the circle? Graph it. If my center is negative 2, 3, I'm going to have x plus 2 squared plus y minus 3 squared equals 26. And I did, in fact, graph it, which you can see. If I look right here, let's see, the center, 0.32, 1, 2, 3, 1, 2. Okay, that's the point that they gave me. That's hard to see. 1, 2, 3, 1, 2. Oh, sorry. 1, 2, 3, 1, 2. Just want to make sure I get it right. Right about there. That's point A, and that was point C. Next page. Use the fact that the tangent at point A is perpendicular to the radius at that point to find the equation of the tangent. It's a really important point. That right there is perpendicular. We're going to use that as we get into circles a little bit in the future. So use the fact that the tangent, which is a line at A, is perpendicular to the radius at that point to find the equation of the tangent line, then graph it. When something's perpendicular, if you remember, the slope is important, right? So the slope of the tangent line is the opposite reciprocal of the slope at AC. So we have the slope of AC is opposite sign and reciprocal. Remember, flip it. Oh goodness. Reciprocal of this new tangent. So let's get the slope of AC. We have change in y over change in x, so 3 minus 2 over negative 2 minus 3 is negative 1/5. So the slope of our new line is positive 5. Using the point slope form, if you remember, y minus y1 equals slope times x minus x1. That's sloppy, sorry. X minus x1. So let's plug a few things in. We have our point was 3, 2. Where's that? Right there. So y minus 2 equals 5 times x minus 3. Simplify that a little bit and we get y equals 5x minus 13. That is what we're looking for. Very fun. So that's the equation of the tangent line, which I drew right there. It crosses way down here at negative 13. Find the coordinates of point B, the second intersection of AC in the circle. So this was A, C, there's B. We're going all the way across. What is that point right there? So if we look at the circle, x plus 2 quantity squared plus y minus 3 equals 26, that circle is a collection of all the points equidistant from the center. So A is on that, so is B, right? So if we're going to intersect this circle with this line, we know what this line is now because we found the slope of it. So point A, oh gosh, I hate when that happens. Point A was 3, 2. Our slope was negative 1/5. So let's come up with an equation. Y minus 2 equals negative 1/5 x minus 3. Multiply both sides by 5. 5y minus 10 equals negative x plus 3, 5y equals negative x plus 13. Cool. All right, so let's use those two equations. We can substitute. I've got x equals 13 minus 5y into my equation. Sorry, 13 minus 5y plus 2. Oh, there's a squared missing up there. Do a little simplifying. 13 plus 2. Okay, FOIL it. 25y. 5 times 15. 30, 60, 75 times 2. So that'd be minus 150y. And then 15 squared. I should have memorized. Is it 225? Yes. Y squared minus 6y plus 9 equals 26. What a mess. Okay, lots of y's. I'm thinking I'm missing a squared here, aren't I? I'm going to check my math really quick. So we have 5 times 15 times 2. That's right. It looks like everything is good. So I'm going to have a 26y squared here. Minus 156y. So I got rid of those. I got rid of those. 225 plus 9. Minus 26 is 208. Whenever you have an equation this big, see if you can factor out the a term. Usually you can. I just checked, and I can. So we get y squared minus 6y plus 8. Yay! That gives us 26y minus 2, y minus 4. Very exciting. So the y coordinates are going to be 2 and 4, right? If y equals 2, plugging it back into one of the equations up there, we get x equals 3. And that's our point right there. So let's do the other one. If y equals 4, 4 is 20, negative 7. So our second coordinate is negative 7, 4, which is right over here. That was a lot of work. Good job. Good job. So I actually still, like, all of this work here is the answer to this question. I did not answer this question. I graphed it on my graphing software, but I have not given you the equation. So the slope here is going to be 5, if I remember right. Yep, 5, and my point is negative 7, 4. So negative 7, 4 with a slope of 5. So we have y minus 4 equals 5 times x plus 7. Y equals 5x. This would be 35 plus 4 would be 39. There's the equation of that line. And the graph is on the previous page. So the last slide, the lines y equals 5x plus b are parallel to the tangent lines to the circle at points A and B. How is the y-intercept b for these lines related to the number of times each line intersects the circle? So we did this, we learned about this in the last few examples. So when b equals negative 13 or b equals 39, the line is tangent to the circle. Okay, those are the y-intercepts. Okay, the slopes can't change, so, if you've got the circle, that one was negative 13, and this one was positive 39. You're only going to get one solution. So this would be one intersection. When B is between those points, you're going to get two intersections. And when B is less than negative 13 or greater than 39, you'll get no intersections. Awesome. Good work.